Hey, welcome everybody to lesson number 3 of Unit 2. We're talking about solving systems by elimination method this time. As I mentioned, there are numerous different ways to solve systems of equations. Graphing and substitution were our first two methods. We're going to look at a new method called elimination today. This method is the one that most people are going to pick as their favorite. And the good news is, if the instructions don't specify how to solve, you can pick whichever method you like. Okay, but make sure you read the instructions. If it says use elimination like today's instructions, we got to use the right method. Okay, so let's look at how the elimination method works. Here are our steps. Again, you want to write these down, so if you need to pause, go for it. Our first step says multiply one or both equations so that each equation contains an opposite term. What an opposite term means is it should have the same coefficient with opposite signs. So for example, maybe we have 2x and a negative 2x, right? Those would be opposite terms. And the way that we would get that is sometimes we might have to multiply if we don't have that set up for us. Step 2, we're going to add those equations together and solve. The whole point of having opposite terms is that when you add, those terms will eliminate each other, hence the term or the name elimination. And finally, step 3, very similar to last lesson's step 3, we're just going to substitute the result into either original equation and solve for that second variable. We want to make sure we go with the original equation rather than the one that we multiplied. Right? We don't want to use the result in case we did our multiplication wrong. Right? We don't want to accidentally use that wrong equation. Okay? Again, your solution types will look the same algebraically as they did with the substitution method. Right? So if you have a false statement, something like 6 equals negative 2, that would be no solutions. If you get a true statement with no variables, like 3 equals 3, that's infinite. Okay, but we're hoping to find solution sets. So let's look at this first example. Okay, our first step tells us to multiply one or possibly both equations so we have opposite terms. I'm looking right here at these x's. They already have the same coefficient. All I need to do is make one of them the opposite, right? One of them should be negative. Doesn't matter which one. Okay, I'm going to do it to this top one. In order to make this a negative 2, I would have to multiply by a negative 1, right? Negative 1 times 2 is negative 2, and that would give us the opposite terms. But the thing is, I have to make sure that when I do that multiplication, I need to do it to everything, including the other side of the equal sign. Okay, and that's where people sometimes make their mistake. Make sure you distribute to everything. So negative 1 times 2x is negative 2x. Negative 1 times 4y is negative 4y. Negative 1 times positive 2 is negative 2. So we just finished step 1. Step 2 says that we need to add these equations together and solve. Now the whole point of step 1 was so that when we do our addition, these x's will eliminate, right? Because they're opposite terms. So when we add those, we no longer have x's. When we add our y's, we end up with 4y. And when we add negative 2 and negative 2, we get negative 4. And then we just have one more step to solve. We end up with y equaling negative 1. Pretty easy, right? We didn't have to do any kind of substitution. A little bit faster there. Now we need to pick either one of these equations to substitute our y value in and solve for x. It really doesn't matter as long as we use one of these original equations. I don't want to use this because I might have made a mistake somewhere. I'd rather use what I know is correct. So we'll use the top one. 2x plus 4 times y, which is negative 1, equals 2. Let's see, negative 1 and 4 becomes negative 4. We'll have to add 4 to both sides and then divide by 2. That gives us x equaling 3. Now we have our two coordinates. We just write them in set notation, 3 comma -1. Okay, that elimination method I think works beautifully. It works almost every time. Let's take a look at this other example here. You might notice here, right, I don't have anything with the same coefficient, but I do happen to have opposite terms. So I might consider trying to make these two numbers match. In order for these two to match, I need to multiply by a 3. Because remember, there's a 1 right here. So that's what I'm going to do. Alright, before I do, I'm going to rewrite this original one. Right, this top one that's not being affected. I want to write it just off to the side. And then I'm going to write whatever the result after my multiplication distribution, I'll write right underneath it. Right, 3 times 5x is 15x. 3 times -y is -3y. And make sure that we go all the way across. 3 times -20 is -60. Now, when I do my step 2 addition, adding straight down, 3 and 15 is 18x. My y is just eliminated. And 6 minus 60 is -54. If we divide by 18, I believe, if I did my math correctly here, let's see, is that 3? -3? 54 divided by 18 is, yes, -3. Just wanted to make sure before I put this on the internet. Alright, now we need to substitute into either of the original equations. It doesn't matter which one you choose. I'm not a big fan of negatives, so I'm going to plug it in up here. 3x, oops, I'm sorry, x we're going to replace with -3 plus 3y equals 6. 3 and -3 is -9. We'll add 9 to both sides. So 3y equals 15, and then we'll divide by 3. Y equals 5. We got both our x and our y. We write them in coordinate pair form. -3, comma 5. Okay, and just like the last lesson and graphing, if I were to plug these in respectively to our x's and y's, they would come out with the solutions that we see here. Alright, let's do a couple more. Here, this example is a pretty good one because I don't have anything that is the same coefficient anywhere. I do have opposite signs, but it's not going to be just one thing I get to multiply, right? This is a little bit more difficult. I need to make sure that these coefficients match. So, if I want those to match, a really nice trick is to just use whatever the other equation's number is to multiply. What I mean is, I see a 7 here and a 2 here. So if I multiply by 2 and 7, right, 2 times 7, 7 times 2, it'll give me the same number, and I already have the opposite signs set up. So that's a nice little trick that we can use. Just use the opposite numbers of what you're trying to eliminate. Alright, we'll do our distribution. 2 times x is 4x. 2 times 7y is 14y. 2 times 25 is 50. Down here, our distribution, 7 times 3x is 21x. 7 times -2 is -14y. And then 7 times 0 is 0. Okay, so I did all of our distribution, and this is what we ended up with. Now we can do our addition. Those y's eliminate. Our x's is 25x equals 50. And then we'll divide by 25. And I get x equals 2. Pretty easy, right? We just used the opposite numbers here. We already had opposite signs. Pretty cool. Let's solve for y now. Let's see, if I did 3 times 2 minus 2y equals 0, that would be 6 minus 2y equals 0. Let's subtract 6 from both sides and divide by -2. I'm getting positive 3. So our solution here is 2, 3. So far we've seen some different examples, right? Our first example, we needed to multiply by a negative in order to get opposite signs. Our second example, we only needed to multiply one of our equations because we already had something set up nicely with the negatives. Here we had to multiply both equations by something. What's this last one going to look like? Oh, geez. Well, I've got all positives and nothing matches. So that means one of these is going to have to be multiplied by a negative. And again, because I want these things to match, well, let's think about it. If I have a 4x here and a 2x here, I need this to become a 4, so all I have to do is multiply by 2. But if I want these to be opposite signs, I need to make sure that I put a negative there. So I'm going to rewrite this first equation. All right, we have 4x plus 2y equals -2. This bottom equation I'll make sure to distribute all the way through, giving me -4x minus 8y equals -10. Combining our like terms, -6y equals -12, and then we'll divide. And I get y equals 2. We'll pick either one of these original equations. It does not matter which one. Let's say the bottom one. 2x plus 4 times, we got 2 here, equals 5. 2x plus 8 equals 5. If we subtract, 2x equals 2. Whoa. Sorry. That should not be a 2. That should be a -3. And then we'll divide by 2. So we got y equals 2 and x equals -3 over 2. We'll have to make sure that we put that into the correct format, and that's our solution here. Don't be afraid, by the way, if you ever feel like your solutions aren't working, you can check them. Just plug in your numbers and see if it works for both. I'm going to do that real quick here because I'm a little nervous. If you want to fast forward 10-15 seconds, go for it. But 4 times 3 is -12, divided by 2 is -6, plus 4 is -2, that worked. That's going to give us -3 plus 8 is 5. So that worked. All right, you can check if you're ever nervous. All right, I've got 3 problems for you. Let's see if I can, no, I'm only going to be able to fit 2 of them on the screen at once. So you're going to have to do 2 of them, pause the video, and check when you're ready to see what your answers are. And then you're going to have one more after that. Alright, let's see what you did. You should have really looked at this y right here. All I need to do is multiply this by 2. If you did not choose that, you really need to look at these problems again and really think about the easiest method here, because if you start doing a lot more work than necessary, they get way more confusing and more difficult. Look for the easy things, opposite signs, nice easy coefficients to work with. Okay, I'm going to make sure that I redistribute all the way through. Step 2 tells us that we need to combine like terms, right, or add them together. So 10x, our y's eliminate. That gives us equals 40. And then we'll divide by 10. I got x equals 4. You might have solved for something else, but like I said, if you're using the elimination method, you probably would have ended up finding x first. If you didn't, I'd really consider you looking at these over again. Now we can plug in to either one of these equations. Let's do this bottom one. 4 times 4 plus 2y equals 18. That would mean 16 plus 2y equals 18. Subtract 2y equals 2. Divided by 2 gives us y equals 1. And finally, you should have wrote your answer as 4, 1. You should have also done this second problem. Okay, this you could have chosen some different things to do, right? Because I have no matching coefficients and I have nothing with opposite signs. So I know one of these things is going to have to be multiplied by a negative. In fact, here's what I'm thinking I'm going to do. I'm going to get rid of the y's. In order to do that, I'm going to multiply by 3 and by 2. Remember, I'm just using the opposite numbers. Okay, but I need one of these to change signs. So I'm going to pick either one. Let's do it to the bottom one. I'm going to make it negative. So let's see. If I do my distribution, 3 times 5 gives us 15x. 3 times negative 2 is negative 6y. 3 times 12 is 36. Bottom, negative 2 times 3 is negative 6x. Negative 2 times negative 3 is positive 6y. And negative 2 times 9 is negative 18. When we combine or add 15 and negative 6 is 9x. Our y's eliminated. That was thanks to our setup here. And then 36 minus 18 is 18. Finally, we divide by 9. X equals 2. Now, you could have done different numbers here. You might have eliminated x and got y first. That was up to you because this is not straightforward telling you which one to go for. Up here, you definitely wanted to go for that y though. Anyways, sorry for the distraction. We want to solve now for y, so I'm going to plug into either one of these original equations. Why don't we go with the top one? If I did 5 times 2 minus 2y equals 12. 10 minus 2y equals 12. Subtract 10. So we get negative 2y equals 2. Divide by negative 2. We get y equals negative 1. So our final answer here, 2, negative 1. You have one more to try. See how you do with it. I don't know. It could be possibly no solutions. It could be possibly infinite. I'm not sure. Pause the video, try it out, and then check your answer after. Alright, let's see. I have opposite signs here, which is good, and all I have to do is multiply this top by 3, and they'll have the same coefficient. They'll be opposite terms. So I'm going to leave this one alone. I'm going to write my result right underneath. 3 times negative x is negative 3x. 3 times 2y is 6y. And 3 times 5 is 15. That's cool. Let's combine our like terms. Positive 3 and negative 3, those canceled out like we had hoped. That was the elimination. Negative 6 and positive 6, oh, those canceled out as well. And you should have gotten a 0 here, right? Because there's nothing left. And on the other side, we end up with a 13. If you see this situation, that's telling you that you have no solutions, right? We had a false statement. Can't solve for either of our variables. That's it for that lesson. I tried to keep it short for you. I think the elimination method is the preferred method. The more you practice it, the easier they get. Alright, I will see you on our next lesson. Bye.